This meeting is being recorded.
Hello and welcome to our presentation. We are from Group 2, EAS 3513 Propulsion. And in the slides, you can see the group member's name and matrix number. So let's begin with the introduction. So Brayton cycle, we'll be talking about Brayton cycle. So Brayton cycle demonstrates the principle of a constant pressure heat engine. The Brayton cycle is usually a thermodynamic cycle which is found in the planes and gas turbine power plants. So from the equation besides, we can see that the pressure ratio increases over the overall thermal efficiency of the Brayton cycle as the pressure ratio increases. So I'll let Sakib continue the presentation.
Thermal efficiency can be improved by following methods. Firstly, increase in pressure ratio. Secondly, heat regeneration. Thirdly, heat reheaters. And lastly, compression with intercooling. Increase in pressure ratio. In general, increasing the pressure ratio is the most direct way to increase the overall thermal efficiency of a Brayton cycle, since the thermodynamic efficiency is primarily dependent on the pressure ratio PR. The compressor discharge temperature rises as the pressure ratio rises, because the maximum temperature that the turbine blades can withstand limits the turbine inlet temperature. The pressure ratio determines the amount of heat that can be added to the flow mode. This generates a leak back, lowering the efficiency of the isentropic compressor. Finally, as can be seen from the formula for thermal efficiency in terms of pressure ratio, the gain decreases as the pressure ratio rises. Now let's move to into environmental consideration. The effect of the environment that needs to be considered is the air quality, climate change, and community noise that have been released because of aviation on local and regional levels. Since the temperature of combustion become higher, the emissions other than carbon dioxide, nitrogen oxides tend to increase. Even though the engine becomes more efficient and cleaner, carbon dioxide and nitrogen oxide emissions that are related to the atmosphere will increase. To prevent that from happening, the change of the combustion cycle can be minimized. While to prevent noise pollution, the design can be modified by changing the engine and the system of aircraft. Now I am going to transfer Farhan to continue his part.
Farhan, you're muted.
So over here we can see the thermal efficiency against pressure ratio graph. So a gas turbine engine with regeneration is used to reduce the pressure ratio. So we can see from the graph beside that the one with the regeneration has like lower pressure ratio. The regenerators use less heat due to the preheat of air using the dismissed energy of exhaust. So the pressure ratio depends on the temperature of the engine. So using a regenerator can decrease the fuel consumption and increase the efficiency of the fuel, which in turn will like reduce the cost. So I'll let Syed continue the rest of the presentation.
To continue with the presentation, the power cycle schematic diagram can be shown below. The normal turbofan engine diagram consists of a compressor, turbine, and combustion chamber. And the Brayton cycle diagrams for the PV and the TS are shown. To the next slide, we can see the modified power cycle schematic diagram. Here, we can see the Brayton cycle with generation, which consists of the compressor, the turbine, the regenerator, and the regenerative Brayton cycle can be seen. The working fluid for this engine is going to be air. A working fluid, the gas or liquid used to transfer force, motion, or mechanical energy. We can use air because it is non-toxic, no global warming potential, and it doesn't damage the ozone layer. To conclude with this presentation, we can see that there are numerous strategies to increase the thermal efficiency of the Brayton cycle while also preserving the environment. The modification is beneficial to the environment since it will have reduced the energy lost by the engine. Less fossil fuel will be required since the energy is used well. One thing to remember is that unlike standard Brayton cycle, the thermal efficiency for Brayton cycle with regeneration decreases as the pressure ratio increases. As the result, Not all pressure and temperature ratio combination result in a thermal efficiency increase. Thank you. So this is the end of our presentation.